Welcome to the course on machine learning. In this video, we will see Perceptron learning algorithm. So the data structure required for this algorithm is X, which is the input data, yi is the target value for sample xi, and yi cap is the output value for xi. W is the weight vector where we will specify the weights of the perceptron, and eta is the learning rate. Generally it is between 0 to 1. Now we will see the steps for the learning algorithm. In the first step, we will calculate net I. The net I for the sample I is calculated as the dot product of the weight vector and the input value, input data of xi. In the second step, we will calculate the output value for xi using the sine function of net I. In the third step, we will find out the change in the weight vector depending on the learning rate multiplied by the change in the y, that is yi minus yi cap into xi, and this particular change in the weight vector will be reflected back into the weight vector of ith sample, that is wi plus delta wi, and the sin n can be specified as it will return the value plus 1 if the sample, or if the value of x is greater than 1, is greater than or equal to 0, and it will return minus 1 if the value of x is less than 0. Now let us see one example. Here we have two input set, x1 and x2, which is a 4 by 1 vector, and x2 is also a 4 by 1 vector. W is again a 4 by 1 vector where the initial weights sets are 1, 1, 1, eta is 0.1, y1 is 1, and y2 is equal to 0. Now the problem is to calculate the change in the values of weight vector after the first iteration. So let us calculate as per the steps of the learning algorithm. So first we will calculate net I, then we will calculate yi cap, and then we will find out the change in the weight vector, and then we will reflect back those changes into the weight vector. So net 1 we will calculate it as net 1 is equal to, so kindly excuse for the error, is W transpose into x1, which is nothing but W transpose is 1, 1, 1 into xy is 0, 0, 1, 1, and the product of this is 1 into 0, 0, 1 into 0, 0, 1 into 1, 1, and 1 into 1, 1. So 0 plus 0 plus 1 plus 1 will return 2. And since the value of this particular net 1 is greater than 0, so the sign of net 1 is yi cap is equal to, y1 cap is equal to sign of net 1 is nothing but plus 1. And now let us calculate the change in the W1. So delta W1 is equal to eta is 0.1 y1 minus y1 cap into x1 is equal to 0.1 into 1 minus 1 into x1 is 0 0 1 1, and since 1 minus 1 returns 0, so everything will be 0, so there is no change in w1. Now let us calculate it for x2. So net 2 is equal to w transpose into x2 is equal to 1 1 1 1 into 0 1 0 1, and 1 into 0 0, 1 into 1 1, 1 into 0 0, and 1 into 1 1. So 0 plus 1 plus 0 plus 1 is equal to 2, and since it is greater than 0, so sign of net 2 is obviously positive, so y2 cap is equal to sign of net 2, that is nothing but plus 1. Now let us calculate the change in the weight vector. So w2, delta w2 is equal to eta into y2 minus y2 cap into x2, which is nothing but 0.1 into y2 is 0 minus 1 into x2 is 0 1 0 1, so this will give us 0 minus 1 1 minus 1 into 0.1 minus 1, so minus 0.1 is multiplied to the x2, which will give us 0 minus 0.1 0 minus 0.1, and this is change in the w2. And now we will reflect back these changes into the actual weight vector. So delta w2 is equal to 0 0.1 0 0.1, and then w is equal to w2, w is equal to w plus delta w2. So this is nothing but 1 1 1 1 plus 0 minus 0.1 0 minus 0.1, and which is nothing but 1 0.9 1 and 0.9. So these are the values of w after the first iteration. So the new values of w are 1 0.9 1 and 0.9. Thank you for watching this video.